Here's an example of the type of problem that we're going to see. Find the volume. Notice that we're doing volume now instead of area of the solid whose base is the area in quadrant 1 that is bounded by f of x equals x, g of x equals x squared, and whose cross sections perpendicular to the x-axis are squares. So what this is doing is this is building off the work that we've done earlier in area, because notice that it's talking about a solid whose base is the area in quadrant 1, blah, 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 blah. If we just look at this section right here and not this last part or this first part, this is something that looks pretty familiar. So what we're going to start off by doing is we're going to start off just by sketching this area just like we would have done before. So we're looking in quadrant 1, so that's up here. F of x equals x. G of x equals x squared. Let me redraw that a little bigger. So we're looking at this area right in here. And when this says perpendicular to the x-axis, that means if our x-axis is here, any little rectangles, cross-sections, anything we're talking about is going to be there. That's our cross-section. There. So what this means is it means we're setting this up very, very similar to what we did previously. We're going to have our little infinitely thin rectangle right there. We've got this width of dx. So far it's looking really, really, really similar to what we did for area. What's different is that now what we're going to do is we're going to take this area that we have here and we're going to draw cross sections coming up from it. Basically, instead of having a rectangle where we find this two-dimensional area, we have infinitely thin little tiny prisms that we're going to find the volume of this infinitely thin little piece. And then we're going to add up all the volumes, just like we added up areas earlier. So there's a nifty little demonstration of that. So let's say here that this was the area that we had it shaded in. So what's happening is that from each infinitely thin rectangle that we draw here, there's a square that's coming up out of the screen to form this kind of weird solid. So if I grab it and I twist it up, we can kind of see right here, it's sort of going up to form this square, and then each point later on, we're seeing that same square that's based on this distance right here. So a whole bunch of little squares. I can keep rotating and kind of get a sense of that shape. But the idea here is that these cross sections coming up out of the page are squares. We could also make those cross sections be semicircles. So here, if I twist it, you can see that's a semicircle coming up out of the page. And we've got a whole bunch of little semicircles coming up like that. Could turn those into equilateral triangles. Here you can see they're nice and pointy like that. There are those equilateral triangles coming up. Rectangles if I wanted. Same ideas. So going back to our problem, an enormous amount of this is going to be the same as what we did for area. There's just a little twist at the end. So I'm going to set this up. Volume It's going to be really similar. It's going to be from our starting value to our stopping value. We're still going to have our width at the end. And we're going to find those the same way that we've done before. There's going to be a little something different right in here. I'm going to hold off on for just a second. But let's start with finding our stopping and starting values. So same thing, we set these equal to each other to find the intersections. So here this x-coordinate is 0. Here this x-coordinate is 1. And so we're starting where x is 0, we're ending where x is 1. We have a dx. What's going to be different is that instead of this part right here being simply the height of this, it's going to be the area of the base. Times the width. That says area of base and we're still going to need what we found earlier in terms of this height here. So this is still top minus bottom, so f of x is this first one here minus g of x, so x minus x squared. I'm going to mark that right here. But now, because these cross-sections perpendicular to the x-axis are squares, instead of just putting this x minus x squared in right here, I'm going to say that this is the base of a square that's coming out of the page, kind of like that. I'm having this sort of infinitely thin square that's going to be the base of my prism. What's the area of this base? Area of the base? Well, I know what the area of a square is. It's just sides squared. And I know that my side is this x minus x squared. So where this is coming from is I'm saying that the area of this square here is side squared, and I know this side is this little height that we found when we were doing area. A quick bit of calculator usage either later, math 9. So we have x minus x squared, quantity squared, comma x, comma 0, comma 1. Ta-da! All done. So let's write out our steps before doing the next problem. First thing is to draw exactly what you would for area. Remember, perpendicular to the x-axis means draw your little rectangle like that. Perpendicular to the y-axis means you're going to draw it like that. So make sure you do those little drawings just like you would for area. You're going to set up your start, stop, and dx or dy values, just like for area. Where we start having slight changes is you're going to label the height of your rectangle on the drawing rather than putting it in the equation, because our equation is going to change a little bit. Write your expression for volume using integral from start to stop, area of base times width. So let's see what that looks like on another problem. Find the volume of the solid whose base is bounded by f of x equals negative x squared plus 4 and the x-axis, and whose cross sections perpendicular to the x-axis are semicircles. So I'm going to start off by just paying attention to the base, which is bounded by, so draw that just like normal. Negative x squared is an upside down parabola, plus 4 moves it up 4, so here's my f of x. Here's the x-axis. So remember, this x-axis is just the line y equals 0. So we can say f of x is negative x squared plus 4. We can say this x-axis is the line g of x equals 0. And the base is this area right here. I'm told the cross sections are perpendicular to the x-axis, so I'm going to draw my line here like this. This is a dx, just like we used before. So I'm going to set this up. It's going to be volume, but it's going to be a dx. And I'm still going to find my starting x and my ending x, so I can find those bounds by setting this and this equal to each other. So this has an x value of negative 2, this has an x value of positive 2. So my bounds are from negative 2 to 2. And now if I were doing area, I would just find this height and put it right in there, but I'm not. So I'm just going to find this height and I'm just going to label it right here. So this height is still going to be the top function, so that's f of x minus the bottom function g of x. We know f of x is negative x squared plus 4, and g of x is 0, so minus 0 just gives us that same thing. Now, remember that for volume, we're going to go start to stop of the area of the base times the width. We've got all of that except for the area of the base. And let's remember that a semicircle, the formula is going to be pi r squared over 2. Because it said that their cross sections are semicircles. Now, I have to figure out what this looks like. So I'm going to have basically little tiny semicircles coming out of this, with this sort of as that flat side. And so I have a whole bunch of little tiny semicircles coming out, but this is the one that I'm looking at in order to set up my formula. Now remember, the r is this distance right here. So this pink distance is negative x squared plus 4. If we cut that in half, we're going to get our r, and we can put it right in that formula there. So our volume is going to be pi r squared, or negative x squared plus 4 over 2 squared, divided by 2. Voila, there's our formula. We've set it up. Again, you can just punch that into the calculator. Be really, really, really careful with your parentheses. So we've got pi, in parentheses, negative x squared plus 4, whole quantity divided by 2, then that whole quantity squared, and that whole thing divided by 2. So I've got one parenthesis around this numerator here, squared, that whole thing in parentheses, squared, that whole thing divided by 2, multiplied by pi. Okay, variable is x. We're going from negative 2 to 2. And there we are.